Welcome to EDU World Space.
So now we'll work on problem 4 from chapter 20. In this problem, we're told to assume that you want to construct a voltaic cell that uses the following half reactions. And we see two half reactions, and we have the standard reduction potential for them. And so it says we begin with the incomplete cell pictured here, in which the electrodes are immersed in water. So let's reproduce this graphic here. We have two beakers, and we have an electrode coming out of both of them. This one is electrode A, and over here we have our voltmeter, and electrode B over here. So the first part of this problem is, what additions must you make to the cell for it to generate a standard EMF? So for this cell to work, we need to add a couple things. We need to add a salt bridge to be able to keep the solutions neutral. And we also need a solution of A2+ in this beaker and of B2+ in this beaker. If we do those two things, we should have a potential. And then the next question is, which electron functions as the cathode? So the cathode is where reduction takes place. So if we go ahead and write down the reduction potentials here below the beaker, for reduction potential for A is negative 0.10 volts, and for B is negative 1.10 volts. So reduction will take place at the one that is more likely to be reduced, which is A. So electrode A will be the cathode because reduction will take place at electrode A. Now for C, part C, it's asking us which direction do electrons move through the external circuit. And electrons, we know, move from the anode to the cathode. So we just mentioned that electrode A is the cathode. So electrons will flow from B to A. And then lastly, in part D, we're asked which voltage will the cell generate under standard conditions, which is 25 degrees Celsius, 1 molar of the aqueous species. So we're going to have the E cell will be equal to the reduction of the cathode minus the reduction of the anode. And in this case, that equals negative 0.10 minus 1.10. So this is equal to 1.00 volts.